Hi everyone. In this video, we're going to look at the geometric distribution. The geometric distribution represents the number of failures before you get a success in a series of Bernoulli trials. That is, a geometric distribution is the probability distribution for the number of identical and independent Bernoulli trials that are done until the first success occurs. For a situation to be described using a geometric distribution, the first condition is an experiment consists of repeating trials until a first success. That is, you conduct the experiment until you get your first success, until you get the success. Number 2, each trial has two possible outcomes: the probability of success, which is P, and the probability of failure, which is 1 minus P. And the third one, which is very important, independent trials are carried out. A discrete random variable x is the number of trials needed to obtain the first successful outcome. If the above conditions are satisfied, we say that x follows a geometric distribution where x follows GOP. The probability that the first success is obtained at the RF atom is probability of x is equal to R is equal to Q power R minus 1 multiplied by P, where R can take values 1, 2, 3 and it goes on infinitely. Now note, x cannot take the value 0 because we are conducting experiments. So you're conducting an experiment a first time, second time, third time, and so on. Now the number of trials could be infinite, however it is not practical. Next is the mean and variance. Each probability distribution has its own unique formula for mean and variance of a particular random variable x. We've seen that for a Bernoulli distribution. We've seen that for a binomial distribution. So the mean or expected value of x for a geometric distribution is expectation of x, or mu, is given by 1 over p. The variance of x, which is defined as a measure of spread of the distribution of x, is given by var of x, or we can use sigma square for a geometric random variable is given by q over p square, where we can also write q as 1 minus p over p square, and var of x, or we can use sigma square. For the expectation, we can use mu. As you can see, the probability of success P is needed to describe the distribution completely. It is known as the parameter of the distribution. So P is known as the parameter of the distribution. Let's consider an example. You sit for a math test and the probability that you pass the test is 0.1. Consider the probability distribution of x, where x is the number of times you take the test until you pass the test. It's the same as when you take your driving test. You're going to continue to take the test until you get your driving license, right? So let's see how we represent this example using a geometric model. So we've seen previously that the probability that the first success is obtained at the RF attempt is what? Probability of x is equal to r q power r minus 1 times p. So what is the probability that you take the test a first time? So your r will be what here? 1. You're taking the test a first time. It's going to be what? Probability of you pass, probability you pass the test the first time, which is what? 0.1. We've seen that probability of success is what? 0.1. Probability of success is what? 0.1. Now, what is the probability of x is equal to 2? This time, your r is equal to 2, which means that you're going to take the test a second time, which means that you fail the first time, second time you pass, second time you pass. What is the probability that you fail? It's going to be what? 1 minus 0.1, which is 0.9. You multiply by what? Second time you pass is what? 0.1, right? Which is 0.09. Let's see when r is equal to 3. Probability of x is equal to 3, which means that you take the test 3 times and you pass the third time, which means you take the test a first time, you fail, you take the test a second time, you fail, and you take the test a third time, you pass, which means that you take what? Probability of failure, multiply by probability of failure, multiply by the probability of success, because you win the third time. 0.08. What can we see from this example is probability of x equals 1 is the same as p. The probability of x is equal to 2. It's going to be what? Q multiplied by p. And the probability of x is equal to 3. It's what? Q times p. So it's going to be what? Q square times p. And it goes on like this. So, and so on. So there we have it, the geometric distribution. Next, we're going to work on some questions. But first, let's look at these two results. If x follows geo p and q equals 1 minus p, then probability of x less or equal to x is 1 minus q power x, and probability of x greater than x is q power x. These two results are going to help you solve some questions that we're going to see in the following video. Let's look at the first question. The probability that an applicant passes the driving license test on any attempt is 0.75. What is the probability that the applicant passes the test on the 4th attempt? We can clearly see that this question represents the geometric distribution because you're conducting an experiment, you're taking a test until you pass the test. It says here, what is the probability that the applicant passes the test on the 4th attempt, which means that he takes the test a first time, he fail. He takes the test a second time, he fail. Third time also he fail. 4th time he passes the test. So how are we going to solve this question? How are we going to find this probability? We start the question by let x be the random variable applicant takes the test until he succeeds. From the question, we've seen that the probability of success is P is 0.75. We describe the model as X follows geo P, where P is 0.75. R is equal to 4. That is, we need to find probability of X is equal to 4. We know that the probability distribution is given by Q power R minus 1 times P. So we have 0.75. We multiply by Q, which is 0.25. Power R minus 1. R is 4 minus 1. We have 0.75 multiplied by 0.25 power 3. 0.25 power 3. You multiply by 0.75. The answer is 0.0117. So there we have it. The probability of X is equal to 4 is 0.0117.